This is the first video in a suite of videos showing you how to use the MEPworx electrical wiring software. So here we can see we're in the electrical section. We have the 18th edition. For legacy users, you can use the 17th edition as well. So we select the icon and this takes us into the electrical program itself. So once in the electrical section, you can see a series of ribbons. Obviously, we haven't started a project yet, so all of the ribbons that are unavailable because we haven't even started a project yet. So we need to get started first of all. Now, you can see here you've got a little pull down. Those are the last projects that you got involved with. And it allows you, the open recent project allows you to open whichever one is highlighted in this header here. We have the project set up, so we've got new, open, and obviously save and save as a grayed out because you have nothing to save. Exit will take us out, and then we have the print, the plot, and the export menus, which we can deal with later on when we've got something to work with. So starting a new project, this brings up the project standard information dialog box. Two standards we can apply, well, three actually. We've got the IET and we've got Australia and New Zealand standards. Well, we'll concentrate on the IET BS 7671. This will then invoke a series of dialog boxes that we need to go through in order to commence our project. In order to complete a project, the bare minimum of the tabs you need to go through are the submains, the final circuits, and the defaults. All of the other tabs are superfluous for the running of the project. These are all about commissioning and can be filled in as and when, or if you actually get involved in commissioning. So, concentrating on the general tab first, we can put a reference in here. And then we go and select our cable database. So all of the defaults are set up to reflect the latest databases. You can actually set up the defaults to suit your own requirements using the default editor in the utilities tool. So if you wanted to change to a different cable database, the program will take you to the installation directory, MEPworx 2021, into DB, and we would go into cables, and we would make the selection from the list here. Well, because it's the latest one, we're not going to do that. We're going to go with the existing one. Here we can see the cable sizes, minimum and maximum sizes. So we can set the goalpost on the minimum and the maximum cable sizes. If the load is such that a single 4-core cable cannot carry the load, and it achieves the maximum of 300 from the listing here, then it'll start paralleling up. So it will automatically start paralleling up based on the requirement when it meets the maximum cable size that we've selected and imposed here. Same with the CPD, the switchgear databases. Again, it takes us to the DB folder. In this case, we would go into CPD and we would select our range of breakers. And there are a whole load of legacy devices and manufacturers' databases in there for existing users who want to pick up existing projects. So there are older devices in there. This particular database is a mix and match of different manufacturers. So you can isolate to a specific manufacturer on the project if you wish. You can also show obsolete CPDs. So for example, if you're doing an existing project, we can then design to use these obsolete CPDs on an existing project. So if you are starting a brand new project, don't show this tick box because it will show obsolete CPDs in the listing, and it can be very tempting to select one that you can't actually purchase anymore, which could be quite embarrassing. Busbar groups we'll deal with in another video. So the start point effectively is your supply conditions. So you can either enter supply fault level, so this would be measured from the local authority figures or figures that you want to use. You can put the external earth loop impedance in there, and you can also put in your earthing type as well. Earthing types can be determined board by board as well. The other alternate method is to use a transformer. So if we were looking at a private network, for example, where we're using 8% volt drop instead of the 6% on public, we could use a transformer. We can select the transformer type, put in our kVA rating, and when we run the calculation, this will then determine the short circuit fault level, the earth loop impedance, reactance and resistances, and the full load current that can be generated using that transformer. Then we select OK to clear that, and that will then populate that data later on. So the next thing for us to do on the submains tabs is to set up the various parameters on the project. So setting up your standard CPD type, You may well have an idea of the loads you're getting at your board, so you may well have an idea of the devices you're going to select. I'm just building this job up on the fly for the training course, so at the moment I'm just going to use BS88s because they're fairly flexible. So when you do your project, in reality, you might be knowing that you've got 70, 80, 100 amp boards, 35 amp boards, whatever, and you might decide to use, I don't know, NS100s or C60s or whatever to protect those circuits. So you will have a better judgment on setting up these devices early on. There's the voltage drop that we discussed earlier on for the public location project type. There's the type of cable. So I'm going to go for low smoke and fumes, and there's the description using the armouring as the CPC. So it's these descriptions have or these abbreviations have a description below them. Standard installation method. Default grouping factor is available. At this point we don't know obviously how the cables are arranged, so that's handled on a cable by cable basis. And then we have the use spare volt drop. So if you imagine you have a large industrial network, we've got very long submains out to boards into sheds, production areas, etc. You might be coming up against it regarding voltage drop. So you can actually use the spare voltage drop on submains, and also you can pass it up forward from final circuits as well. So if we go to the final circuits, you use the same thing. We can optimize the voltage drop so that we could take any spare volt drop downstream and pass it upstream, or any spare voltage drop upstream and pass it downstream. If we use both, it will optimize. If we don't tick those boxes, what it will do, it will use 4% submains, 4% final circuits as the benchmark for the voltage drop, and then tell you that you may have voltage drop issues if your cables are too long. If you do get that, what you can then do is come back to here and tick these boxes, and then any spare can be passed upstream or downstream to offset any problems you might have with your cable installations regarding voltage drop. Final circuits is the same, standard CPD type, so I can select my devices that I want to use. So I'm going to go and select a range of devices. These are all listed, so I might select, for example, an IC60, and you can see the rating from 2 to 63 amps, and you've got the fault level. So this gives you an idea of whether the device is suitable based on the fault level we've got at the supply. Again, we have our voltage drop, our standard cable type. So all we're doing here is effectively setting the defaults on the project. Every individual cable can be changed and deviate from the basics that we're putting in here. We also have the defaults. Standard voltages, single and three phase, power factors, default temperature. This for discrimination faults is the worst case scenario at the end of the cable. Our standard core type auto, we could set these parameters, but leaving it at auto will also have a bearing on whether you're using the neutral cable for balanced load. So if you tick that box, what this means is you're going to use a 4-core cable irrelevant of whether you've got balanced or unbalanced. So you're adamant that you want a balanced load to have a 3-core and an unbalanced to have a 4-core, untick the box. Then you have the working area size of the screen. So the screen you can see here represents what we call the home screen. You could zoom right out to 9 screens or 25 screens. Basically, the electronic size of the paper you're working on can be made bigger as the project progresses. We'll then move on to video number 2 and show you how to actually set up the project. So there's our area, our home screen. So if I go to the view menu, then we've got the zoom all. So there's 9 screens or 25 screens, depending on the selection we make in the general information. If I wanted to change it, or if I want to change any of the information, I can go to the edit menu, select general. That brings up the general information back. Go to defaults, change this to 5x5, or any other parameters on any of these dialog boxes. Then go back to the view menu and select zoom all. So we've now got 25 screens. So if we're getting a bit tight on space, just expand the screen area and then take that back to the home screen.